Hello everyone. So we're going to continue with units and dimensions, and this time we're going to look at dimensions and dimensional formula, this subtopic. So what are dimensions of physical quantities? We've seen that there are 7 fundamental quantities, or we can also call those base quantities. There are 7 of those: length, mass, time, electric current, luminous intensity, temperature, amount of substance. These are the 7. There were 2 supplementary quantities also we learnt about: radians and steradians, or angles and solid angles. But for now, we'll stick to the fundamental quantities. Now, what we've done is we've given each of the fundamental quantity a symbol. These symbols are accepted worldwide. So for length, the symbol used is L. For mass, you can see the symbol used is M. For time, the symbol used is T. For electric current, similarly, we have I. For temperature, it's theta. For luminous intensity, it's J, and for amount of substance, which is measured in moles, is N. Now, these are different from their SI units. Remember, before this, we've studied about SI units. So the SI unit of length was, if I have to write the SI units here, the SI unit of length was meters. For mass, it was kg. For time, it was seconds. For electric current, it was amperes. For temperature, it was Kelvin. For luminous intensity, it was candela. For amount of substance, it was mole, MOL, mole. Yeah, this was these were the SI units, but their symbols are a little different. Okay, symbol is how we represent the measurement of length, mass, and time. So L, M, T, these are the symbols that we are going to use in dimensional analysis. So remember these symbols. So we've seen what are the symbols of the 7 fundamental quantities, what are the different symbols. Now, when these symbols are put inside square brackets, they're called dimensional formula of length, dimensional formula of mass, dimensional formula of time. So the symbol put inside a square bracket is now called the dimensional formula of that quantity. At times, we might have to find the dimensional formula of some derived quantities as well. Like you can see, momentum, force, power, these are some derived quantities. Now, derived quantities are expressed in terms of fundamental quantities only. So, if we know the symbols, individual symbols of the fundamental quantity, we can put those symbols in the dimensional formula of the derived quantities also. And that's how we get the derived quantities dimensional formula. But we are going to look at dimensional formula a little later. For now, let's just focus on what is this term dimension. What does this term mean? What is dimension? So now let's try to represent momentum with the help of symbols of the fundamental quantities. Momentum, we know, is mass times velocity, right? That's the formula for momentum. Mass is measured in kilograms, and velocity, the SI unit for velocity is meter per second. Meter per second. If I have to express momentum in terms of the symbols of these fundamental quantities, kg representing mass, so the symbol that I will use is m. This symbol represents mass. Okay. Then meter. Meter is length. So that's represented by L. So ML, M is multiplied with L, and upon time. Okay, upon time. So ML upon T, or you can write it as MLT minus 1. So what is dimension? Coming back to our original question. So the dimension is the power to which a certain symbol is raised. So the dimension of time in momentum, in the dimensional formula of momentum, the dimension of time is -1. The dimension of mass is 1. Yeah, because mass is raised to the power 1. So can you tell me what is the dimension of length in the dimensional formula of momentum? What's the dimension of length? You will see length is also raised to the power 1. So we would say in momentum, the dimension of length is 1. Okay. Similarly, dimensional formula for force and power is given. What is the dimension of length in power? The dimension of length is 1 in power. Okay. So as you can see, length is raised to the power 1 here. So that's what dimension is. I'll repeat, dimension of any physical quantity is the power to which the fundamental quantities are raised. Okay. You can read the definition that's given here. You can read this definition and that would tell you what dimension is. As an example, we took momentum, force, and power to understand what are the dimensions of individual fundamental quantities within the dimensional formula of momentum, force, and power. I hope this part is clear because this is our stepping stone to the next part, which is understanding what dimensional formula is. Dimensional formula of fundamental quantities are their symbols itself. It's very simple, as I also discussed it before. For these fundamental quantities, these are their dimensional formulae. Okay, so symbol put inside a square bracket, that's their dimensional formula also. So if someone asks you, write the dimensional formula for temperature, you do this. You write the symbol, enclose that within square brackets. This is the dimensional formula for temperature. Okay, so for fundamental quantities, it's very straightforward. What about derived quantities? For derived quantities, we express the derived quantity in terms of units of fundamental quantities. Once we have done that, we will replace those units with the symbols of fundamental quantities. Let's try it out with this example. We are going to express acceleration. We're going to write the dimensional formula of acceleration. So first, let's write the unit of acceleration. Acceleration is given by rate of change of velocity or velocity upon time. The unit would be the unit of velocity, which is meter per second, upon the unit of time, which is second once more. So meter per second square or meter second to the power -2. Now these are units. Okay, these are units. Meter is the unit of length. Unit of length. And second is the unit of time. Unit of time. How do we represent length? What is the symbol of length? The symbol we've just seen, length is represented by this. What is the symbol used for time? It's T. But here in this unit, T or seconds is raised to the power -2. Okay. So using this part, we've got this part. Now this LT to the power -2, LT to the power -2, when placed inside square brackets, this gives you the dimensional formula of acceleration. Now, LT to the power -2 is the dimensional formula for acceleration. This can also be expressed like this. Do you agree? I'm saying this is the same as this. Why? Because m to the power 0 is basically 1. So we can write that. Okay, m is raised to the power 0. Now, the benefit of writing it like this is if someone asks us what is the dimension of mass in acceleration, we can say it's 0 because we can see it directly. Okay. All right, let's move on and see what kind of questions have appeared in JEE mains.